This is Algebra 2 with Trig, 1B.3, working on our second day. We're going to talk about the graphing in standard form. To graph in standard form, we need to look for the axis of symmetry. That's going to be found using the opposite of B over 2A. That is your formula to find the axis of symmetry. To find the vertex, you're going to use the line of symmetry and plug it back in to find the y value. You're going to use the vertex in the middle of your table and pick values to the left and to the right. A good value to pick is where the y-intercept is. That's the c value of your equation. We're going to reflect a point and we're going to draw a parabola. There's always a neat little video here besides the one I'm obviously making you, but there's even a better one for a couple minutes that you can see it all worked out by somebody else. Here's standard form. We know this is standard form because we have an A value, a B value, and a C value. So we're going to find our axis of symmetry, or line of symmetry. To do that, we use x equals opposite of b over 2a. Well, I like to use the word opposite of b because if b is negative, we don't fall into the trap and call it a negative. The opposite of b, which is negative, it's going to become a positive. It's the opposite of what it was. So two negatives make a positive. So it's 8 over 4, which is 2. You have a line of symmetry at 2. So we like to label that on our graph. So to find the vertex, we're going to take our x value of 2 and we're going to plug it into our equation. So our a value is 2 times x, which we calculated to be 2 squared, minus 8 times 2 plus 7. When you calculate this out, you have to do your squaring first. Here mathematically it wouldn't change, but it can change if it's not both 2's. So you got to square your parentheses first, which is 4. 8 times 2 plus 7. Then your 2 times 4 is 8. Here we would get negative 9. And when you do that calculation, we get negative 1. So our vertex is 2 comma negative 1. So put your vertex in the middle of the table, 2, negative 1. Now we're going to look for other points. There's a couple different ways we could do this. We could use our knowledge of our parent function, which is over 1 up 1, over 2 up 4, over 3 up 9. You could use that knowledge, and you would have to double everything you went up. Over 1 up 2, over 2 up 8, over 3 up 18. That would be perfect. We can also take our table, come over to our y-intercept, which is 2 steps to the left, which was x is 0, will be your y-intercept, and that's your c value. You know you're at 7. 1, 2, 3, 4, 5, 6, 7. That's a pretty easy way to land at 0, 7. Now watch this reflection point. I'm going to go 2 steps to the right to get to my line of symmetry. So now I'm going to go 2 steps to the right of that, which is x equals 4, to get to my next point. If it takes 2 steps to get to the line of symmetry, I'm going to go 2 steps after that. So if it took 2 steps to get to line of symmetry, I'm going to go 2 steps. That has to be at 4. I'm up at 7. Now I need to find a value that's in between those. There's multiple ways we could do this. We talked about the parent function, which would be over 1 up 1, but we need to times it by 2, so it's over 1 up 2. Over 2 up 4, but you got to times it by 2, so it's up 4 again, and voila, we're right there. It worked great. So you can use that knowledge, or you can just say y equals 2 times 1 squared minus 8 times 1 plus 7. That is 2 times, or that's 1 times 1, which is 1. So 2 times 1 minus 8 plus 7. That's 2 minus 1, which is 1. So when x is 1, y is 1. Then to figure out where I'm going to be at 3, it's going to be reflected across that line. You don't have to recalculate it. It's going to be at 1. And then it would be good if you wrote your equation. And there you've graphed it. You can talk about your reflection point, which was really big here or even here. And we can always do the comparing, the parent function, the domain and range, the end behavior. We can do that all off the graph, off the equation. Let's come see the next one. To find the vertex, I need to use negative b, or opposite of b, over 2a. I know my a value is negative 1, my b value is negative 4, and my c value is 2. So I'm going to say negative 4 over 2 times a. That gives me a value of negative 2. Then I'm going to use negative 2 to plug into my equation. The opposite of negative 2 squared is, it's x is being squared, not the negative. The negative is not in parentheses here, so the square is only affecting the x. So when we plug in a number as x, the negative is still on the outside. We don't call that positive yet, we got to square first. Minus 4 times negative 2 plus 2. So that's 4 times negative 1, which is negative 4, plus 8, plus 2. That gives me 6. So I have a vertex at negative 2, 6. That goes in the middle of my table. Since I'm at negative 2, I'm going to put that on my grid at x equals negative 2. And I'm going to go up to 6. 1, 2, 3, 4, 5, 6. So now a common thing that we like to do is look at your C value. That's going to be here at 2. So that's 2 steps to the right. That's at 0. 2 steps to the right is at 0. When x is 0, we're at a height of 2. I can reflect that to the line of symmetry and past it, so I know I have another dot over here, another point on my graph, which is 2 to the left, 2 more negative, negative 3, negative 4, so I'm out here at negative 4, I'm also at 2. So you just found a reflection point. On your test, it might ask you for the reflection point. and you would say you have a reflection point of negative 4, 2, because you found that point purely by reflecting it over the line of symmetry. You can find your other points very easily by understanding what the parent function would be. 1 over, and 1 times 1 is 1. So you move, in this case, down, because it's opening downwards, but it goes down 1. Over 2, down 4, right there. Over 3, down 9. You square your value. So you can find that very quickly. If you're not confident with that, you can say what happens when x is negative 1, and you can plug it into your equation. Negative 1 squared minus 4 times negative 1 plus 2. You could do it like this. That's 6 minus 1, which is 5. 1, 2, 3, 4, 5. And I'm going to land 1 unit away anyway. And I reflect it. So at negative 1, I'm at 5, and negative 3, I'm at 5. So now I'm ready to draw my parabola in. So we've graphed our equation, we write our equation. Now my domain for any parabola is all real numbers. The range is from your vertex, in this case going down, so it's less than or equal to 6. My end behavior, as we've done it before, you always start out with these x terms. As x looks to the left and as x looks to the right. You start out with that. As x approaches negative infinity, as x approaches positive infinity. Now we ask ourselves, what is the y value? A lot of times we call it f of x, but in this case it's called y, so I'm just going to use y. Y approaches, what happens when I go to the left on the graph? It goes down to negative infinity, and as I move to the right, it also goes down. Every parabola, these will go in the same direction. The comparison, we start out with r because there is a reflection over the x-axis, and there is a translation 2 units left, 6 units up. There is no stretch or shrink because the a value is just 1. A value is negative 1, but there's no extra multiple.
Reflection is when a is greater than 0. Okay.
So here, it looks tricky. It's been in our previous homeworks. There's no b term. So you can write this as y equals 2 x minus h, which is 0, squared minus 5. If you like vertex form, call this vertex form. It's 0, negative 5. 0, negative 5. 1, 2, 3, 4, 5. And we're going to use this other method. The parent function goes over 1 and up 1. I'm going to go over 1 and up twice that amount. The parent function goes over 2 and up 4. I'm going to go up twice that amount. And in both of these cases, I can reflect it across my line of symmetry. Those are some quick ways to help you graph out your parabola. So that was pretty quick. But the parent function is 1 over 1 up, 2 over 4 up. Because the a value is 2, we're going to go up twice that amount. My axis of symmetry, or line of symmetry, is right on the y-axis, x equals 0, I can reflect them right across. So I have a point at 1 comma negative 3 and 2 comma 3. At negative 1, I'm still at my negative 3. And at negative 2, I'm at the same height, which is up 3. So I could fill up my, oops, sorry, I was filling out the table at that point. Sorry about that. My line of symmetry same thing as AOS. My end behavior, we are working with as x approaches negative infinity and as x approaches positive infinity. When we look to the left, the graph is going up. When we look to the right, the graph is going up. We'd like to write our equation for the graph. Okay, 3 more quick ones down here. Tell whether the function has a minimum value or a maximum. Here I know that the a value is less than 0, so it's going to open up, it's going to open downwards because it's negative. So that means it has a maximum value. Find the maximum value. Well, in this case, I'm going to have to first do negative b over 2a. That's my line of symmetry. So I plug in my b value, I plug in my a value, and that's 10 over negative 4. So that's 5 halves. 10 fourths is 5 halves, and it would be negative. Then I have to plug that in. That's a little scary. So here we're going to get negative 2. We're going to get 25 fourths when we square that. Here we'll get a positive 50 halves. And we'll get 7. So our 2's can cross out, so we'll get 25 divided by 2. Here this is 25 plus 7. So this is 32. So instead of using 32, I'm going to use a denominator of 2 and call it 64. Now 64 divided by 2 is 32. When I minus 20, I get 44, so this is going to be 39 halves. Yikes. So that's my minimum or my maximum value. $19.5. Okay. So find it and remember that it is the y value of the vertex. Okay, we did our work. Let's check out this one. The a value is greater than 0, so that means it has a minimum. And the vertex we know is at 1128, so our maximum value is at 28. Then my last question, we know the p value is at 1 and the q value is negative 3. Since my a value is less than negative 2, or less than 0 because it is negative 2, we're going to have a maximum. So I need to find my p plus q divided by 2, which is 1 plus negative 3 divided by 2, which is negative 1, and I plug that back into my equation. And to do that, We calculate our values, and we get 8, which is a positive 8. So my y value, my maximum value, is at 8.